Welcome everyone to our Tao Salon. This is our space for finding that simple, elegant path right through the middle of the often complex world of statistics. And today, we're starting at the very beginning with the single most important idea you need to get your head around.
Let's be honest. We are swimming in data. It's everywhere, all the time. And if you're trying to make sense of it, it can really feel like you're just lost in this giant sea of numbers and charts. It's a lot.
But what if I told you there's a map, a really simple way of thinking that can bring some serious order to all that chaos? Well, today we're going to build that map, and we're starting with the one fundamental building block of all data.
And this is it, the variable. That's the secret. A variable is just any piece of information that changes. So think about it. If you record the age of everyone in a room, the characteristic is age, but the actual number changes from person to person. That's a variable. It is the key to absolutely everything we're going to talk about.
Okay, so let's dive in. The very first step on our map is this huge, powerful split. Every single variable you will ever see falls into one of two big families.
So on one side, you've got categorical variables. These are all about sorting things into groups. Think of them as labels. And on the other side, you've got numeric variables. These are for recording actual quantities, actual measurements. It's groups versus numbers. That's the first great divide.
Let's make this super concrete. Country of birth. Well, that just sorts people into groups, right? So it's categorical. Age, on the other hand, that's a measurement. It's numeric. How about has disease, yes or no? Yep, that puts people into one of two buckets, categorical. And weight? That's a recorded quantity, which makes it numeric. See? Pretty straightforward.
Okay, now that we've got that first big split down, let's zoom in on that first family, the categorical variables. Because it turns out not all categories are the same, and this little distinction is really crucial for knowing what you can and, what you can't do with your data.
So first up, we have what are called nominal variables. Basically, these are categories that are just names. There's no natural order or ranking to them. One isn't more or less than another, which is why, for example, you can't calculate the average hair color. The math just doesn't work.
Just think about it, right? You can't really say that brown hair is mathematically bigger than blonde hair, or that Canada is somehow higher than Japan in a meaningful way. They're just labels. They're nominal.
But sometimes categories do have a logical order, and when that happens, we call them ordinal variables. Here, the sequence actually means something, which gives us a little more statistical power. You can now find a middle value, like a median, even if you still can't really do an average.
Coffee size is the perfect example, right? Large is definitely more than medium, which is more than small. Same thing goes for survey ratings. A 5-star review is obviously better than a 1-star review. There's a clear built-in ranking. That's what makes it ordinal.
Now this is where people get tripped up. It's a classic trap. You might see data where yes is coded as a 1 and no as a 0, or a 5-star rating is just the number 5. But the key thing to remember is that those numbers are not for doing math. They are just placeholders, a kind of shorthand for the real category. And this example just illustrates the difference perfectly. Let's say we all go run a 10K race. Your race time, 55 minutes, 32 seconds, that's a precise numeric measurement. But your finishing place, first, second, third, that is an ordinal variable. It's a ranked category. First is faster than second for sure, but the time gap between them could be anything.
All right, let's hop over to the other side of our map, the numeric family. This is where we get to do all the fun stuff, like calculating averages and making predictions. But first, we just need to understand one final split. Are we counting things or are we measuring them?
Okay, so discrete variables are for things you can count in whole numbers. You can have 0 people, 1 person, or 2 people in an elevator, but you can't have 1.5 people. The values are distinct, they're separate. The key takeaway here is super simple. If you find yourself asking how many, you are probably dealing with a discrete variable. The number of patients in an ER, the number of cars in a parking lot, all of these are countable, whole number things. And the other type of numeric data is the continuous variable. This is for stuff you measure, and these can take on literally any value within a range, down to an infinite number of decimal places if you could measure it that precisely.
We might say someone weighs 57 kilograms or that they're 35 years old, but their true weight could be 57.258 something, and their true age is 35.738 something.
Weight, age, temperature, income, they all exist on this smooth, continuous scale, even if we usually round them off to make life easier.
So there we have it. We've built our map, we have our big divide, and we have our subdivisions. But let's get to the real question. Why does any of this actually matter? Let's connect this whole framework back to the real world.
Here they are. These are the 3 key questions to take away from our little salon today. Think of these 3 simple questions as your guide. If you ask them, you can classify any piece of data you come across. And that is the first and most critical step in any analysis, because it tells you exactly which statistical tools you're allowed to use.
And look, knowing this isn't just some academic exercise, it's a superpower. In business, you're using categorical data like a person's country to figure out who your customers are. You use ordinal data from surveys to understand how they feel, and you use numeric data like sales figures to track what they do. Getting the variable type right unlocks the right insight.
And that's the flow. You now have the fundamental map for navigating the entire world of data. This is the foundation that lets you move from confusion to clarity, from just having raw data to making a real discovery. So the only question left is, what will you explore first?